Guys, welcome to your asynchronous lesson. It's going to be like a normal lesson, except for there won't be a chat box or call and response. So a little different, but the idea is kind of the same. We're going to go through a warm up, we're going to go through some practice problems, and then you'll have to do an exit ticket. And the rest of your class time, because this isn't going to take 2.5 hours to go through this video, is going to be for working on your homework. Okay, so what I want you guys to do is to try this warm up and pause it here, or wait a second. I'm going to talk through them, give you guys a little bit of a hint as I go, and then you'll pause it and try it on your own. So first, I want you guys to solve this basic log. So remember, to solve these, we have to put them in exponential form, set them equal to something, change it to exponential form, and kind of use our math common sense. Okay, for expanding the following log, remember that's when you're looking at quotient, product, then power. There is a little bit of a caveat to this one though, because the whole thing is being raised to the power of 2. Can see that? So you have a couple options. You saw this on your homework. You can either bring the 2 down at the beginning, or you can multiply it in. Okay, then for condensing the following logarithmic expression, you're going power, product, quotient. And there's 2 things you have to be careful of here. The first one is, if I look at this right here, I have to think of what dividing 3 is as a coefficient, right? We don't have a property for when the whole log is being divided by something, but we do have a property for when the whole log is being multiplied by something. So think, can I write divide by 3 as multiplication? The second thing we have to be careful of is we have 2 subtraction signs here, and we can't use the quotient rule when we have multiple things being subtracted. So what we actually need to do is factor out that negative and make it so that we have addition inside the brackets, parentheses, and then we can use the product rule there. Okay, so pause this video now, try these out on your own, and then as soon as you hit play, we will be going over them. Okay, so ideally you pause the video and now you're coming back to see if your answers are correct. So for this first one, what we're going to do is I'm going to set it equal to question mark. I'm just going to say, okay, this equals question mark, and then I'll change it to exponential form. Because what I'm asking myself is 5 to the what is 1 over 625. That's what I'm looking for here. And what I want to do with that is recognize that it is a fraction. It looks like it's been flipped, right? So really, we want to take a second. We want to do a little bit of a sidebar and say, okay, well, what is 1/5? You know, you can think of it like this. 1/5 to the what is 1 over 625. Or in your little sidebar, you can think, okay, oops, I gave you guys the answer. You can think 5 to the what is 625, right? So here, that's going to be, as I showed you, 5 to the 4th. So we know in order to make it a reciprocal, it has to be negative. So our answer here is going to be -4. Okay, and that's kind of the thought process that we walk through. Okay, for expanding, right? I told you we were in a little bit of a tricky spot because we had this exponent on the outside of everything. Now, what some people like to do is they like to use the power rule at the beginning to bring it down and then just work from here. You are allowed to do that. That is okay. You just have to be careful that make sure, you know, at the end of the day, when it's all expanded and you've got all these, you know, natural logs, whatever, that you keep these brackets along the outside to show that that 2 is multiplied to all of them. Okay, that's not my favorite thing to do. My favorite way to do it is to multiply in the exponent, right? We know properties of exponents say, if I have, you know, a to the 3 over b all to the 6th, I can, and sure, we'll throw a c in there too. When I have exponents on division and multiplication, I can kind of distribute them in. So this becomes a cubed to the 6th over b to the 6th, c to the 6th. And then we also know when I have exponents stacked like this, I can multiply them. So that becomes a to the 18 over b to the 6th, c to the 6th. I like simplifying my exponents at the beginning of the problem so that I only have I only have to do the power rule once, and I can do it at the end of the problem. but it's really up to you, right? It's your answer. So long as it's right, it's right. But I'm going to distribute that in. So I'm going to have natural log of x squared plus 1 squared times y squared over x squared, and then z cubed squared, you multiply those, is going to be z to the 6. And I always like to draw my z with a little line between it so that I don't accidentally think it's a 2 when I'm solving the problem. So when I do expanding, I always start with the quotient rule, right? Now that I've got that simplified. So that means that I can take things being divided inside of a log and separate them into subtraction outside of a log. So this will be natural log of the numerator, which is x squared plus 1 squared times y squared, minus natural log of x squared times z to the 6. So that's my quotient rule done. Next, I have to use the product rule. And I actually have to use the product rule twice, because if you look here, I have multiplication happening inside of both logs, right? I have x squared plus 1 squared times y squared. That can be separated by addition, or to addition. And then I have natural log of x squared times z to the 6. So that's multiplication as well and can be separated to addition between the logs. So I'll take natural log of x squared plus 1 squared plus natural log of y squared minus natural log of z squared plus natural log, or x squared, of z to the 6. And then we have to be careful here because we know that if we were to recondense this, we would have to follow PEMDAS, but also we need to get with what we started with. So I'm going to put these in brackets or parentheses to show, hey, I do this before I do the subtraction, right? Even though addition and subtraction you do from left to right, I need to do the product rule first. I need to do this addition before the subtraction. Okay, and then last but not least, we can just use the power rule to bring down our exponents, right? That's the last step. And they all have an exponent because I distributed in at the beginning. So this will be natural log 2 times natural log of x squared plus 1 plus 2 times natural log of y minus 2 times natural log of x plus 6 times natural log of z. Okay, you could distribute in the negative sign if you wanted to, but you don't need to, and I wouldn't. So now I just real quick want to show you guys what this would look like had I not distributed in that 2 at the beginning. So my answer could also be, I would put brackets on this around the whole thing to show that that 2 was on the whole thing, and then the only term inside that had a exponent on it was the z. So these are the same exact answer, just depends on how you started it, how your final answer is going to look. All right, we're like 10 minutes into class and still on the warm-up, but what is new? The last one we had to do here was a condensing problem, and condensing is the opposite of expanding, so no surprise that we do the properties in the opposite order. We're going to do the power rule, then the product rule, and then the quotient rule to get this fully condensed to a single log, right? So we have log base 6 here. There were 2 issues I mentioned in my little hint in the warm-up that we had to take care of. The first one is, instead of thinking of dividing by 3, right, x divided by 3, that's the same as x times 1/3. So we need to think of this as log base 6 of z squared minus 1 times 1/3, right? So I'm just gonna cross that out, and I'm gonna put a 1/3 right there, okay? Because that's much easier to use the power rule on, right? We don't have a rule for when you're dividing the whole thing by something. And then the last thing we have to take into account is similar to what we had to do on the tail end of this problem, right? Where we had to add in the brackets. Here, we have 2 things being subtracted. If we were just to condense this and do the quotient rule, we would end up with a fraction inside of a fraction, or a triple-decker fraction, which is not okay. That's not something we can deal with. So what we need to do is say, oh, I'm going to factor out this -1, so it's clear that we are both of these are in the denominator and they're being multiplied together. And then when we do our steps, we can see that that's the case, right? You know, algebraically, we talked about this in class. These are the same thing. We want to do the addition first so that we don't end up with a crazy fraction over a fraction. So first though, before we can do any of that, we need to do the power rule. So I'm going to go ahead and bring up my exponents. So we'll have log base 6 of x plus 1 to the 4th plus log base 6 of z squared minus 1 to the 1/3. Remember, that's a cube root, minus log base 6 of 7y plus log base 6 of x squared. Okay, remember, you do need to show your steps. You do need to show your work, even if you at this point can condense it in your head. On your quiz at the end of the week, I'm going to need to see your steps for you to earn credit. Okay, then what we need to do is do our product rule, and again, we have to do it twice. We can take these arguments and put them in a single log because there is addition between them. That's a z. And we can take these arguments and put them in a single log, and multiply them because there's addition between them and they have the same base. Okay, so now our first term's looking a little crazier, but we have 2 terms left. When you are condensing, you should only ever have 2 terms left when you do the quotient rule, because what's going to happen is this piece is going to be your numerator and this piece is going to be your denominator. And if you have more than 2 pieces, then you don't just have a numerator and a denominator, you have a problem. Again, as I said, this will be log base 6 of that whole thing will be my numerator, and the other will be my denominator. Okay, and we're done. All right, so we are not going to spend time in this asynchronous class going over the homework answer key because I won't be able to take questions anyway, and it's fairly self-explanatory. So the homework key is posted. I show all my steps. Please email me if you have questions. And then also Wednesday office hours, they're only from 1 to 1:50 this week because we have staff training at 2 p.m. But you'll also have time in office hours on Wednesday to ask questions about it and prepare for your quiz. Okay, so take a look at that at some point today. Now we're going to move on to learning target 3. There's not much more to learning target 2 except for practice. At the end of class, you'll see I have a study guide ready for you guys to practice some more. But as far as learning content goes, there's no more to learn in learning target 2. It's really just practicing until the quiz on Thursday. Okay. So we're going to move on to learning target 3. I can solve exponential and logarithmic equations. There's actually 4 different ways, 4 different types of equations we are going to learn how to solve in this unit or in this learning target. We're going to start with 2 of them today, and these are the log ones, right? It says I can solve exponential and logarithmic equations. We are starting with just the logarithmic ones today. There's 2 strategies for logarithmic and 2 strategies for exponential. Okay. They have to do with the properties we kind of already know, plus a new one. So the first one is going to be the first strategy 1 is switching between exponential and logarithmic form. That is something that we're already familiar with. That's something we already know how to do. We did it when we were graphing. We did it in learning target 2, but now we're just doing it in a little more of an advanced way. Okay, so we know this property. Now we're going to use it to solve more complicated equations. Okay. To be able to use this strategy, for it to work, you have to have the equation look like the property, right? And the property looks like I have a log on one side and something else, a single something else on the other. Okay, I don't have multiple things. I don't have multiple logs. I don't have logs on both sides of the equations. I simply have log here, something here. Okay, so that is what we need for this to work. A single log on one side and 1 term on the other side. Okay, now honestly, you could do it with more than 1 term on the other side. We're just not really going to do that level of problem. Okay, and then also we may need to condense to make this true, right? To have a single log, we may need to condense it down, right? If we have addition between logs, we can turn that into a single log using the product property. Okay, so we may have to condense some time to make that true. So the first example, this already checks out, right? It checks both our boxes. We have a single log on one side and a single term on the other. So now I can switch this into exponential form, and you really have to know that property. So I'm going to write it down right here. Log base b of x equals y is the same as b to the y equals x. Okay, you really have to be familiar with this because this looks kind of complicated here. So unless you're familiar with the property, it's hard to do. But we have our base is x, right? Our base stays the same. Our output, which is 2 here, becomes our input. So it's x squared equals our input of our log becomes our output of our exponential equals 6x plus 16. That's just a quadratic, right? Honestly, the only thing I'm teaching you with any of these strategies is the first couple of steps. Everything else is algebra 2 or algebra 1 level. So when we see a quadratic, that tells us, hey, you need to get that equal to 0, right? I like having a positive x squared. So I'll move everything to the other side. Now we have a quadratic. Now we factor. Okay, what multiplies to negative 16 and adds to negative 6? Okay, again, that's what I was talking about at the beginning of the semester when we spent that time on factoring. You got to know how to factor, and you got to know how to do it quickly because you have 10 minutes to do this problem. You can't be spending all of that time on factoring. Okay, this means my solutions are 8 and negative 2. Okay, and here is the work just a little nicer, right? I'll even in the property, I'll match everything up. So base stays the same. Output becomes input. Input becomes output. Okay, so that's how the switch was made. Then it's just a quadratic, and from there we're just solving a quadratic. Okay, pause this video if you need to write this down. Okay, here's the thing about logs. With all of these, just the logs, so just the ones we learned today, you have to plug it back into the original and check your answer. Okay, we had some very strict restrictions on the domain and base of a log. Right, there were two things. The first one was that by definition of a log, and honestly an exponential, the base must be greater than 0 but not equal to 1, right? It was always, okay, you've got your base, but it has to be greater than 0 and it cannot equal 1. Well, negative 2 is not greater than 0, and it's also not equal to 1, but it's a negative. We can't have a negative base. So our only solution is x equals 8 because it checks out. Okay, so that's something you're going to get more and more used to as we solve these and do these, is that you have to check your answer. You've got to plug it back in and see if it works. If it works in the domain and if it works in the base. Though, you know, often there's not a variable in the base, but when there is, you got to check it. Okay, strategy 2 is the property of equality, the logarithmic property of equality, which is not something you guys have learned yet. But it's basically saying if I take the log of something and it's equal to the log with the same base of something else, those somethings, the arguments must be equal. And I know that this makes sense to you guys. It just looks a little different here because we can do it with anything, right? If I have 2 times x equal to 2 times 4, you know that x has to equal 4. So in the same way, if I have 2 times x equals 2 times y, you know that x equals y. So it's the same thing here. We're not dividing by a log. We're not canceling a log. You can't do that. We're just saying that if the logs are equal, then the arguments must be equal, right? If log base 8 of x minus 2 is equal to log base 8 of 5, then what's inside the logs must be equal because you're doing the same thing to them and it's equal. So x minus 2 equals 5. You solve, you get x equals 7. Okay, that is strategy 2. Again, you may have to condense to get here. And I'm going to write that down so you guys write it down. May need to condense. Again, which is, you know, when I was talking about you'll see a use for condensing, this is a use for condensing, right? We can only use this when there is exactly and only one log with the same base on each side. It has to look like log of something equal log to something. If there was like an extra 6 right here, can't do it. That's strategy 1. If there's an extra log here, okay, I can do it, you know, log of z, but first I have to condense it to log of y times z. Okay, so that is what has to be true to use this property. All right, so looking at this problem, we already meet the requirements to use this property, right? It says log base 5 of 2x minus 5 equals log base 5 of 3x. I could rewrite this, though, as if I took this and I rewrote it as log base 5 of 3, I don't know why I put a base 3 there, log base 5 of 3 plus log base 5 of x, we would have to condense first, right? We can't get rid of the log. We can't set what's in the log equal until we have single log, single log. So in some cases, you will have to condense before you can set them equal. But in this case, there's already a single log on each side, which means that the arguments must be equal. So we can set 2x minus 5 equal to 3x. We'll do negative 5. Subtract 2x from both sides. Okay, so x equals negative 5, right? Again, this is like algebra 1 level solving. The trig part is being able to use this property, being able to get it to be a single log equal to a single log and setting the arguments equal. Okay, so we can see x equals negative 5. But now we have to think back to when we were graphing log functions. We had restrictions on the domain, right? We had, you know, log base b of x equals y. The domain was 0 to infinity. You know, if there were shifts happening, it shifted, but the whole point was I couldn't take the log of a negative number or 0, right? If you try and type like natural log of negative 6 into your calculator, you'll get a domain error. It doesn't work. We can't do it. So we need to, for every single log problem we solve, we need to check our answer in the original equation. So we have to plug negative 5 into the original equation. It's not the fact that it's negative that makes it not work. It's the fact that when I plug it in, I get a negative. Okay, so it's not just the fact that x equals negative 5. The x value can be negative, right? We saw on some of the log ones we graphed, the domain would sometimes be like negative 3 to infinity, which means that some negatives are okay. The issue is when you get it down to taking the log, you end up taking the log of a negative. Okay, so negative 15 does not work. The important thing to write down here is that you cannot have 0 or a negative in the base or argument of your log. It's not that the solution can't be negative, it's that you can't take the negative, or you can't take the log of a negative. Okay, your argument cannot be negative. Okay, so for this one, the way I can determine what strategy it is I see that there are multiple logs, but also everything has a log, right? If this was just a 2, you know, a lone 2, I would know that I'm using strategy 1 because I have, you know, something without a log. But if every term has a log, you're able to condense it down to log equal to log. And the only condensing we need to do here is we have this addition, which can be condensed to multiplication. Now we have a single log on both sides, so we can set the arguments equal. So to do that, I'll have, I'm going to multiply that out. 2 equals x times x is x squared, x times 1 is 1x. Again, this step, trig. This step, trig class. The rest is algebra 2, algebra 1, right? This is solving a quadratic. X squared plus x minus 2 equals 0. What multiplies to negative 2 and adds to positive 1 is going going to be x plus 2 times x minus 1, which means that my solutions are x equals -2 and 1. But I always have to check my answers to log equations. You always have to check. And we check in the original equation. Yes, they will work in this. Yes, they will work in this. But that's not the problem I gave you. We've got to check them in the original equation. So the first one, x equals -2, will leave us with log 2 equals log of -1 plus log of -2. That's not going to work. In two situations, I'm taking the log of a negative, and that's not okay. Okay, it's not the fact that x equals -2 itself is negative. It's that when I plugged it in, I ended up taking a negative or having a negative in the log. For x equals 1, I don't actually have to check and see if it is, accurate, right? We can't do log base 2 of 2 in our calculator. But what I can do is see, okay, positive, 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 this checks out, right? That's when I say check, we're really doing a domain check. We're making sure that we wouldn't get, an undefined answer. So x equals 1 works, which means that that is our only solution to this problem. Quick recap, strategy 1 is switching between exponential and logarithmic functions. It's only called strategy 1 because I decided to teach you guys it first. The strategy is switching between exponential and logarithmic functions. Remember, you have to have a single log on one side and a term on the other. So if you ever have an equation that has some terms with logs and some terms without, that means that you are eventually going to use this strategy, but you have to use, combining of like terms and log properties to get it to be in this form so we can change it to this form and solve. Our second strategy was the property of equality, right? If you have a single log equal to a single log with the same bases, you can set the arguments of the logs or what's in the logs equal to each other. Again, you may have to condense to get this to be true. If every single term has a log, that is when you can use this strategy. Okay, so that's it for like the lesson part of today. I just want to go over a few housekeeping things and what to expect for the rest of the week in terms of homework and quizzes and all that. So there is an expanding and condensing study guide on Schoology. It is extra practice to help you prepare for quiz 2. Quiz 2 will be this Thursday for you guys, Friday for second and fourth period. It'll be 2 questions, 10 minutes each. The first 10-minute question will have a solving basic logs and an expanding question in it for 10 minutes. The second one will be a 10-minute question on condensing. I'm giving you guys 10 minutes for the condensing one because it's a little more than just doing it. There's going to be some handwritten, sentences and explaining you have to do. Okay, we'll continue to work with Learning Target 3 on Wednesday. We'll go over Learning Target 2 a little bit. Okay, later this week, I'll post the video of me going through the study guide. And then I'm not making it homework. It is recommended to prepare for the quiz though. Do some of it, do the section you need most help on, but you can earn a bonus point for doing it. I figure if we make a study guide for every quiz, that can be up to like 10 bonus points throughout the semester, which, it's not going to make or break your grade, but it can always, if you forget a homework, lose a point here or there, this can help you. The real reason you should do the study guide, though, is to prepare for the quiz. Okay. The last thing you have to do for me today, other than watch this video, is an exit ticket due by 4 p.m. Okay. To earn your attendance for today, you need to have completed the SED puzzle, which is thankfully for you guys almost done, and submit the exit ticket. Okay. As soon as both of those are complete, I'll mark you present for the day. Unfortunately, because that's how we're taking attendance this time, it has to be submitted by 4 p.m. because I can't submit attendance at like 11 p.m. Okay, at 2 p.m., I'll send an email out to anyone who hasn't completed the assignment just to be like, hey, you got 2 hours to get your attendance for the day. The exit ticket is in the Learning Target 2 folder and the homework is in the Learning Target 3 folder. Only this ed puzzle and the exit ticket need to be completed by 4 p.m. The homework, which is here, just needs to be done by Tuesday at 11:59 p.m. Okay, it's a long worksheet that I have an answer key for all of them, but you only need to do numbers 5, 7, 19, 21, 11, and 26 to practice these two strategies. Email me if you have questions, but other than that, I will see you guys Wednesday, and have a great rest of your asynchronous day.